Hey everybody, it's time for another installment here for your quantitative reasoning course. We are in section 6C, all right, and I'm actually going to break this up into two sections. The first half is going to be the 68, 95, 99.7 rule. All right, that's what this video is going to cover, and then we'll do the second half of section C in a different video that'll be posted, right afterwards. So anyhow, so this whole chapter or this whole section is based on something that is called the normal distribution. Okay, so the normal distribution is when your data is in the shape of what's often called a bell curve. And so in your textbook, they give you this idea here, right? That the normal distribution, the data is spread like this. So these are the data points left to right, and this is the frequency of the data. In the middle, the mean is right in the center at the highest peak, and then your frequencies are higher close to the mean, and way out on the edge you have almost no data out on the edge, right? That's what it means to be normally distributed. And so not all data is normally distributed. So anytime we are dealing with stuff from section 6C, we're assuming a normal distribution. You can't just assume one in general, but for us, we are going to assume a normal distribution. And so anytime you see problems from this section, part of the problem will have to say assume that the data is normally distributed, or assume a normal distribution. All right, otherwise everything we do in this section, it doesn't work for all data. It only works for data that is normally distributed. Okay, so what does something look like if it's not normal? If it's not normal, it looks like, oh sorry, just kidding, haha. No, not normally distributed data, all right, would look something like this. See, it's kind of spread out where lots and lots and lots of people, frequencies are high to the left, but then very, very few are anywhere else. Whereas this one here, part A, this guy is close to being or very much approximating a normal distribution because the highest frequencies happen in the middle and the lower frequencies happen on the end. Okay, so that's what we're talking about with regards to a normal distribution. All right, now as far as the rule that we're talking about, the 98, 60, or 68, 95, 99.7 rule, that is a general rule that applies to normal distributions. So you can read the rule right there on your ebook, page 399. 68% of the data, approximately, these are approximations. That's, if we want to get more specific, that's what the other video will cover, is getting more specific. But if we're just doing some approximations, 68% of the data approximately is located between one standard deviation of the mean to the left and to the right. 95% of the data is between two standard deviations of the mean, both to the left and to the right. And then almost all the data, and sometimes if you don't have very much data, all of the data, but in general 99.7% of the data approximately falls within three standard deviations of the mean. Okay, so let me do an example to kind of show you what in the world we're talking about here and what this means. So in your worksheets, you've got this picture in your worksheet. This is in your textbook also online, but in the worksheets I have given you those pictures, and then you have this is work right out of your textbook. Okay, and so here we are going to do problem number 19. So here we're saying that a set of test scores is normally distributed with a mean of 100 and a standard deviation of 20. Okay, so let's draw a picture of what that looks like. Since it's normally distributed, this is for number 19, we are told that the mean is 100 and the standard deviation is 20. And so what that looks like then is we draw this out. Okay, I'm going to go ahead and draw my curve first. Guys, I'm not an artist, and I don't expect you to be. So I'm not going to be picky if it's not perfectly symmetric or whatever. Just make sure that you get the points in the right spot and that kind of thing. So the mean happens at the highest point. This is the mean, okay? And so the mean is what? That's 100. And we have a standard deviation of 20, which means we're going to count by 20. So if I add 20, here I get 120, right? Plus 1 standard deviation using the notation from the textbook, right? That's plus 1 sigma, all right? And then if I go to the left, that's minus 1 sigma, and that is the number what? That's the number 80, right? So let me put the minus 1 sigma a little lower, minus 1 sigma, and so if I subtract 20 from 100, I get 80. So what does that mean? That means that 68% of the data is between a score of 80 and 120. Okay, that's what that means. That's how that works. Now, if I go 2 standard deviations, that means I add 2 standard deviations to the mean. This is always adding to the mean, so really I'm just adding one more, right? So 2 20s is 40, 40 plus 100 is 140. If I subtract 2 standard deviations from the mean, I'm down to 60, and so what our data tells us then is that 95%, approximately 95% of the data is between 2 standard deviations. So 68% of the data, the points, are supposed to be between, and again, these are approximations, right, are between 80 and 120. If it's normally distributed, 95% of the data are between 60 and 140, right? And so then if you went one more, if I went 3 standard deviations to the left, that would be subtracting 3 times 20, which is 60. So I'd get a 40 over here, and that would be adding 3 would be adding 60, so that's 160. And so between these two, we would have 99.7% of the data, pretty much all the data, unless you had a huge data set, right? 99.7% of the data are between 40 and 160, right? So that doesn't mean there isn't anybody that scored below a 40 or above 160, but it means that almost everybody lies within these two spaces, right? And obviously these are building upon itself, right? If you're between 80 and 120, you're also between 60 and 140, okay? But the way that we can do these problems then, the way that we can use this to answer questions is once you've kind of drawn this all out, then you can use the percentages because there's 100% total, right? 100% of the data, so everybody goes somewhere, okay? And so if you come back to your picture, sorry, to your, wrong one, to your questions here, right? Then they ask you for the percentages of how many are less than 100, less than 120, less than 140, blah, 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 blah. All right, and so what I'm going to do here is I'm going to snip this, not that, obviously. I'm going to snip this out, okay? And take a picture of this and move it. It's not a very good one, so let's try it one more time. You see the fun of doing this kind of thing here. The picture's a little bit sideways. That's my problem here, so that's all right. All right, so we're going to copy that and then bring it over into our notebook. Just to extend the page a little bit, right? And so we can put that in there, and let me move it down. And actually, I can shrink that a tiny bit. Maybe. All right, so I can definitely shrink that a little bit. There we go. Okay, so ignore 18 there. All right, so let's answer a couple of these questions again based on the picture that we've drawn and the information that we have. So how do we do that? So if we take a look at question A, what is 100? 100 is the mean. The definition of the mean is the middle, right? Pretty much. And for a standard deviation, for a normal distribution, the mean really is the middle. The median is the middle, but in a normal distribution, the median and the mean are exactly the same value. And so the 100 is the middle number. And so how much lies below the mean? Well, half the data. So 50% of the data lies below the mean. You don't need your standard deviation stuff for that at all. Okay, but now, let's take a look at B, less than 120. Okay, so let me see if I can show you how to do this. If we split this down the middle, right, what does that mean? That means that there are 34% of your data is on that side and 34% of your data is on that side. In other words, this 68% is split evenly between 80 to 100 and 100 to 120. So 34% of my data is between 100 and 120. Okay. And then we just found, right, we just stated that 50% is below 100. So if you want below 120, then you take all of it that's below 100, and then you add the stuff between 100 and 120, and so you get 84% of the data is below 120. And again, these are approximations, right? These are approximations if you're using a z-score table, which is what we'll do next. For those of you that have seen it before, you'd get numbers that are slightly off, and so that's okay. These are approximations. Don't worry about that. All right. So this is the process. This is how you do that. All right. So let me do maybe one more here. Let's jump to letter D, less than 60. Well, where are you if you're less than 60? If you're less than 60, oops, I don't want that. Okay, if you're less than 60, then where are you? You're in this area right here. I'll color it a different color. I'll call it green. All right, so you're over here. Okay, well, how much is between these two? This is 95%. Is from here to here, which means what? That there's only 5% outside of these two. But it's not 5% total. It's not 5% on both sides. It's 5% total. So it's actually half of 5% on this side, and it's half of 5% on this side, right? So if you go from 140 all the way out and from 60 all the way down, right? 95% of the data is between 60 and 140, which means 5% are not between those two. And so another way to read that is to say that 5% is less than 60 or more than 140. And because the normal distribution is symmetric, right? 50% on the left and 50% on the right, that means half of 5% is less than 160 because the other half is more than 140. Okay? And so half of 5% is 2.5% is below 60, or less than 60, whatever. Okay? So you just kind of have to draw the picture every single time, guys. You have to draw the picture every single time. All right? So what I'm going to want you to do is I'm going to want you to work through problems, these problems on your worksheet. Okay, all your worksheet is together, but specifically we're looking at problems 16 all right, through 24. 16 through 24, all right, deal with this type of problem. So, sorry, 19. So 19 to 24 are the problems on your worksheet that specifically deal with that. That there's a worksheet copy from your book, right? And so that's what that is. And then the very last page of your worksheet, gives you ones. And so these, and I will always say use the 68, 95, 99.7 rule. I will always say that, okay? And so when you're looking at your numbers, all right, that's what I'm talking about. I'll say that. If you don't hear that, that's when you use the z-score, and that's the rest of it, okay? So this set from 19 through 24 are the only problems that really go with our 68, 95, 99.7 rule. Everything else, all right, goes with the stuff that we'll do next, okay? So that's the first part of section 6C, and take a look at those few problems there, and I will give you I will break up your My Math Lab homework as well. So the My Math Lab homework, I have two parts. One will be with the 68, 95, 99.7 rule. The other one will be regular with the normal distribution with the z-score, okay? And I'll post that video here in a little while. All right? Thanks.